this is Caroline from the Blue Crew, FTC Team 6417, here to give a quick tutorial on how to get started programming your robot with Android Studio. Now, obviously, the first thing you want to do is you want to install Android Studio if you haven't done so already. And that is going to be where you are going to be developing the code. That is going to be the IDE that you're going to be using. The next thing you want to do is you want to install the Rev hardware client. So the Rev hardware client basically acts as like an Android device built into the control hub. So if you're using the control hub to control your robot, you're definitely going to want to install this software so that you're able to load Android code onto the control hub. The hardware client is right now only available on Windows computers. So yeah, after you have both of those softwares downloaded, you can go ahead and access the code. Now, the code for the FTC robot controller is available on a GitHub repository created by First Tech Challenge, and you're going to want to make sure that you are using the latest version of the robot controller. So I'm going to put the link to the current version as of 2021 in the description. However, if you're looking at this from a future season, the current version might actually be a different repository. So make sure you're looking at the right repository. As you can see, if you go to their profile, there are many different repositories. Some of them are for previous years, such as Skystone. You can see that's archived, so you don't want to use Skystones if you're currently trying to code for Ultimate Goal. So let's go back to the FTC robot controller repository. To access the code, you don't need to sign in, but you might want to have a GitHub account anyways, because to copy this code, you are going to want to fork it. So what a fork does, it just makes a copy of all this code and puts it into your own GitHub account. So go ahead and hit fork right here. Since I already have a fork of the robot controller, I don't need to do that again. I'll just go to what I have. Let's hit the link here. So this is our current repository that contains the Blue Crew's code. And if you want to download this code, there are two ways to do it. The most straightforward way is right here. There's this big green button. It's a bit hard to miss. You hit download, and you can download it as a zip. And then once you download the zip, you can open it in Android Studio, so I'm sure you know how to do that. The other thing you can do is you can import it into Android Studio using version control. So if you just copy the link right here, that is the URL for the repository, so let's copy and paste that. And once you go to Android Studio, if you're using Android Studio for the first time, you're probably going to have to sign in to GitHub. So just go ahead and go to File, Settings. Once you're in Settings, there are all these options on the side. Hit Version Control, go down to GitHub, and then you can click the plus button on top, and you can sign in with your login and password like that. So I'm already signed in. You can see my account right here. And once you're signed into GitHub, you can go ahead and hit File, New, Project from Version Control. And then right after that, you can paste the link to the GitHub repository into the box where it says URL. You hit clone, and then it makes a copy of all that code downloaded onto your computer's drive. So I'm not going to do that since I already have that downloaded. But once you open the file, you're going to see there are two main folders. The first folder is FTC Robot Controller. And the next folder is team code. So FTC Robot Controller holds all this example code that first provides you. And team code is where your team's actual code is going to be. So let's go ahead and open FTC Robot Controller Java org that first inspires the FTC Robot Controller, and we go into the package called External Samples. And here's a huge list of classes that you can use as templates for your own code. So the ones we're going to be focusing on right now are Basic Op Mode Linear and Hardware Pushbot. So let's go ahead and open those two and see what they look like. So hardware pushbot is a template for your robot's hardware map. And what the hardware map does is it links the hardware of the robot to the software so that you can actually program it. So the hardware pushbot reads the information in the configuration of the driver station and assigns that to variables in the code. So as you can see here on top, it creates all these instance variables that set up the actual components of the robot. So you can see public DC motor left drive equals null. So it's null in the beginning. You're going to set those to actual values later. If you want to make a servo, you can do public servo. Let's say you're using a sensor, you can go ahead and go public color sensor, or public color sensor color equals null. So that's just an example. Let's get rid of that. Here are some constants that you might want to use during your program. So if you have any constants you want to declare, some common constants are the CPR of your motors. I'll talk about what that means in a future tutorial. And maybe like the diameter of your wheels, things like that, that will come in handy for calculations later. And here are local op mode members. So there's the actual hardware map, and there's this elapsed time variable that pretty self-explanatory, tells you how much time has elapsed. You're not going to be using that too much right now. And then the important part is right here, public void init. So this function initializes the hardware members, it basically gets the hardware map that is configured on the driver station that's on the phone, and it gets all those values in the configuration and assigns them to variables in the code. So let's say that on the phone you have a motor called left drive right here. So how to access that in the Java code is you would go left drive equals hardware map.get dcmotor.class. So this first parameter, this first argument, tells you the type of component it is, and then the next tells you the name that is actually configured on the configuration. So this is like if you typed in left drive on the phone, that you want to type left drive here. So that's what it does. Then you can change the direction of the motors, forward or reverse. So since the motors are on two separate sides, and they're like on one side is flipped, you're going to want to put the left side and the right side in different directions. So you can see here the example puts left drive to forward and right drive to reverse. And then you want to set all motors to 0 power. That's pretty self-explanatory. You don't want your motors to be running when the program starts, so you want it to be off at first. And then you can set it to different modes. So I'll talk about encoders and all these different modes later. You can do the same thing with servos, so just get all that from the hardware map. So that's basically what init does. Init will get the data that's from the phone and put that into the software. Now let's go to basic op mode linear. Actually, no, a better idea would be for us to look at how we've implemented that in our own code. So let's go into team code before we look at the op mode. So team code, Java, org.firstinspire.ftc.teamcode, and then you can see we have all our code here, all our classes here. So let's go into hardware 6417. The convention is to name your hardware map hardware, and then your team number. So as you can see, we have a whole lot more motors than actually are in the example. So we have 4 drivetrain motors, we have shooters, we have our intake motors. We're also using the IMU. I'll talk a bit more about these later. And here are our constants. So we have all those declared in the top of the class. Now let's go to our init function. You can see it's like pretty much the same as example, except we've named them differently. For example, so we have front left configured on the phone, so that's how we're going to assign it in the code. We have servos. We have the IMU. So that's basically what we have. And in our hardware map, this is not an example, but as you progress throughout the season, you're going to want to add all these different methods so that when you want your robot to do something, you can just access the method to do that in the hardware map. So we have a method to shoot using the flywheel. We have a method to intake. We have a method to drive to position. Here's a different version of our driving method. Here's our strafing method. Here is the set drive speeds method, and that'll come in handy in the op mode that I'll talk about later. So you can see all these different methods that we have here. I'm going to put the GitHub repository for our code in the description in case you want to see how the code will look like in practice, like aside from just the templates. And let's go on to our linear op mode. So here is the linear op mode template. As you can see on top, there is this annotation, teleop, and then it has two parameters. Name is basic linear op mode, group is linear op mode. So group doesn't matter all too much. It just like kind of helps you sort the different op modes, especially useful if you have a lot of them. Name is what's important though, because name is going to be what shows up on the driver station. So let's say you want it to show up and have the name op mode. So if you just change the name, then there's going to be a button on the driver station that has the label op mode, and that's how you know that this is the software that you're about. This is the function. This is the program that you're about to run. The next line has this annotation called disabled. So you're going to want to get rid of that when you're actually putting it into practice, because disabled means it's not going to show up on the driver station. So let's just put it back for now since it's just a template. So basically on top you have your instance variables. So we don't actually need this. So you can see that you might recognize this from the hardware map. It's really similar. You set an instance variable for the motor. So because some teams don't use a hardware map, sometimes they put the actual hardware stuff in their op modes. So since we have a hardware map right here, we don't need to do that. That makes the code a bit more organized to look at. So let's scroll down to run op mode. Run op mode is what is actually called when you hit init on the driver station. So first it says initialize. Telemetry is one way to make information appear on the driver station, and that's really helpful for debugging, and I'll go into that on a future video. Right after that, you can see that in the template, they are getting the values from the configuration. So we already did that in the hardware map, so there's no need to do that in your actual code. Next, we have wait for start, and that's really important because what this does is it waits until the drivers have hit the start button on the driver station. We're not allowed to move before, or yeah, we're not allowed to do anything. You can like, I guess, set up, you can initialize servos and stuff. So you might like move the servo to a certain position. We do that sometimes, but you can't actually like drive the robot or anything before the game starts. So it's important to wait for start, wait for the driver to hit play, and after that you'll see this while loop while op mode is active. That is a loop that runs throughout this entire throughout the entire game. So until the time is up, this is going to be going on forever and ever, or not forever. It's just going to be running through all of this code right here, all this code real fast. And it's going to go back up to the top and do it again and again. So you know how while loop works, I presume. Right here, we are going to, during this section, we're going to take input from the gamepad, and we're going to convert that to actions that the robot can actually do. So let's go to our own op mode. So what we have right here in team code, we have this class called mechanism drive op mode. And as I said before, you want to comment out disable so that it shows up on the teleop or on the driver station. And then afterwards, you can see that we don't actually set up the motors and everything like they do in the example code. So here they're like getting all the motors from the configuration. We don't do that since we already have this handy hardware map. So instead of doing all that, we have this one line right here. Hardware 6417 robot equals new hardware 6417. You might recognize that as a constructor of the hardware class. So basically, we create this object called robot, and robot is going to be calling all the functions that are inside of the hardware map class. And when we go to run op mode, the first thing we do is initialize the hardware map, robot.init hardware map. And you'll recognize this init method from the hardware map right here. So this line right here, what that's doing is it's invoking this function, this method that we defined in the hardware map here, public void init. Then after that, it's kind of the same. We wait for start. And here, we are getting input from the joysticks on the gamepad. So we get the left stick, its vertical amount, and we get its horizontal amount from like both left and right sticks from gamepad 1. And we use this method called set drive speeds to individually set the powers to the different motors on the drivetrain. So you can see like there are many different buttons on the gamepad. Left trigger, left bumper, right bumper. Let's say instead of left trigger, we want to make this controlled by the A button. So you just hit A. That's a true or false Boolean value. So that's gonna give you a problem, right? It can't compare, a Boolean value to a double. Let's control Z that. So you'll notice that some of the inputs are Boolean values and some of the inputs are doubles. So on the gamepad, that makes sense, right? So there are some buttons where it's just if you press it, it's pressed. If you let go, then it's not pressed. But there are some controls where if you press it a certain amount, so let's say the joysticks, you can like move it all the way up, or you can move it just a little bit up. Those are going to be returning double values, numerical values, and tell you like to the extent how much you are pushing the joystick up. So this is pretty straightforward. If the drivers are doing something, if the drivers hit the left trigger, then it's going to intake. So you can see that is pertaining to gamepad 2. You can change, if you want the first driver to do that, you can just change it to gamepad 1. So let's put it back to gamepad 2. So we have all these different methods here, or all these different if statements here that call all these different methods on the hardware map, depending on what button the drivers are pressing. So that is pretty straightforward. Again, I'll put all this code in the description, or the link to this code in the description. Here we have a function called nudge. So that's just like this one function that our robot does. It just moves like small amounts. That's pretty helpful. And yeah, that's essentially it. So again, I'm going to be putting the links to all the resources in the description below. So this is it for the hardware map and the teleop. So this op mode is going to be used since it's like getting input from the gamepads. Those are going to be used during the driver control periods. But next, I'm going to be talking about what to do for autonomous, how to make the autonomous code, how to make the robot run by itself. So yeah, I hope this video is helpful, and I'm going to be making future videos in this little quote-unquote series of tutorials. So thanks for listening, and best of luck with your coding.